हाय एवरीवन, आज हम डिस्कस करेंगे कि सेमीकंडक्टर्स क्या होते हैं, कितने प्रकार के होते हैं एंड वो काम कैसे करते हैं. आई ट्राई टू refrain from using heavy mathematics in explaining the current flow in these devices, right? So what are semiconductors? Semiconductors are devices जिनकी conductivity properties lie करती हैं somewhere in between conductors and insulators, and we can control the flow of current through these devices by exploiting some properties. For example, by changing the electric field applied across it, voltage, by shining a light on it, or by increasing the temperature, right? So ऐसा कैसे होता है, right? So as we first we'll discuss semiconductor devices बनते कैसे, and then we'll move on to key how conductivity happens through them, right? So semiconductor can be of multiple types. First can be a single element semiconductor, which is made from one of the device, right? That could be a silicon diode, a germanium diode, right? And कुछ होते हैं multi element. These kind of semiconductors are basically used in electrical components like PN diode, right? कुछ मल्टी एलिमेंट सेमीकंडक्टर्स होते हैं जैसे कि गैलियम आर्सेनाइड, राइट? आई थिंक यही होता है गैलियम आर्सेनाइड का सिंबल, पर एनीवेज या these semiconductors are broadly used in, for example, making LEDs. Some various combination of these elements can make various colors, right, and so on. Okay, so moving ahead, let's say we have a silicon crystal. A silicon crystal would have multiple silicon atoms, right? For example, like this, right? This is one is a silicon atom, right? Each silicon के पास उसकी outer most shell में 4 electrons होते हैं. Now ये हुए 4, right? So now to form, since now it has 4 electrons and it needs 4 more electrons to complete its outermost shell and become to gain stability, what it does is it shares one electron from the nearby atom to form a covalent bond. So now this electron is shared between this Si atom and this Si atom. Similarly, all on the 4 side, like this would be connected to this, and so on, and that's how the one Si atom is sharing each electron from 4 of its neighboring atom to form a stable combination, right? Now at room temperature, at 0 Kelvin, not room temperature, 0 Kelvin, all of these bonds would be intact and there would be 0 electrons, right? Where's the pen? Okay, 0 electrons. So conductivity would be 0, right? Current would be 0. But as the temperature rises, some of these covalent bonds break, right? And what we have is we have some free electrons that can move freely across the crystal, right? But as the temperature increases, the number of covalent bonds that break increases and number of free electrons increases, right? And when we apply a constant voltage through this type of crystal, we get a current, right? Anyways, so this is what this is how semiconductors produce current, right? This bond breakage can happen either by increasing temperature. We can apply a electric field, and we can give show some light which can break these covalent bonds, right? Now also, to increase the conductivity, what we need is this is the single element, right? Now what type of, there are also different type of semiconductors that can be there. For example, this was an intrinsic semiconductor, wherein there was no, all the atoms were of same type only, right? Now we can increase the conductivity by increasing the number of free electrons by doping, by a thing called doping, right? In doping, what we can do is we can replace one of these crystal by some mechanism with some other element, right, which could have greater than the 4 electrons, free electrons that 4 valence electrons that Si atom has. For example, generally, let's say we have replaced one of the Si atoms with phosphorus. Now phosphorus has 6 free electrons. 5 free electrons, right? And five free electrons, and all of these the 4 electrons would be participating in the covalent bond, but one of this electron would be free to roam anywhere. So that's how you increase the number of free electrons. As the doping increases, the number of free electrons increases, and when we apply an electric field or whatever, we break these by increasing temperature, we break these covalent bonds, the number of free electrons increases, and thus we can increase the current, right? So also, instead of having phosphorus or a higher group element in the doping, we can have a lower group element in the doping. For example, we can add some other element as well, where the number of free electrons is less than the 4, right? So that's how we have a vacant space. Now that vacant space can be filled by any free electron, right? So that's what we call a hole, and this hole is used as a free space. Whenever an electric field is applied, free electrons can occupy this space and create a hole in its original place, and that's how we can have a flow of electrons, or flow of hole basically is considered as a positive element, whereas electron is considered as a negative element. So moving ahead, so this was the basic explanation of how semiconductor devices are formed. Clearing everything. Now where are semiconductor devices used? Semiconductor devices are used in basically any and every digital device that we use. For example, they could be used in computer chips, CPUs, mobile phones, etc. Yeah.